Newly released image of 3 Atlas confirms it's not a comet. Researchers are freaking out right now, and NASA's in total panic mode. The Webb telescope just sent back its latest data on that weird Comet 3I ATL, and holy crap, nobody was ready for this. Remember how they told us it was just an unusual interstellar object? Yeah, that was a massive lie. The chemistry is all wrong. Carbon dioxide levels are off the charts, and it's literally spewing pure nickel with 0 iron. That's physically impossible according to everything we know about space. Even crazier, this thing is accelerating on its own and maintains perfect mechanical rotation. The top minds at Harvard are now asking the question nobody wants to voice. Are we actually witnessing first contact? The day space telescopes went into panic mode. August 6, 2025 started like any other day at the James Webb Space Telescope Mission Control Center. Scientists were running their usual scheduled observations, everything calm and predictable. Then, at exactly 2:11 in the morning, Greenwich Mean Time, everything changed. Marco Macchi's voice crackled through the communication systems, urgent and clip. The numbers coming in from ground telescopes were showing something that shouldn't exist. Less than 6 minutes later, something unprecedented happened. The most expensive space telescope ever built received an emergency override command. Every planned observation got pushed aside. The delicate ballet of Webb's orbital schedule, planned weeks in advance by committees, suddenly didn't matter anymore. This was only the 4th time in the telescope's entire operational history that such a drastic measure had been taken. The target was an object called 3I Atlas, an interstellar visitor that had been quietly approaching our solar system. What started as routine tracking had turned into a scientific emergency. Ground-based telescopes had detected something in this comet spectrum that made no sense. The object was accelerating in ways that defied physics, and its chemical signature was breaking every rule astronomers thought they knew about comets. The Webb telescope had to move fast. The comet's trajectory was shifting by the hour, and the window to get clear readings was closing rapidly. Mission controllers watched nervously as their billion-dollar observatory pivoted in space, its sensors locking onto a target that would challenge everything scientists believed about visitors from other star systems. When chemistry goes completely wrong, the first data packets from Webb's near-infrared spectrograph painted a picture that left scientists staring at their screens in disbelief. 3 Atlas was pumping out carbon dioxide at levels never before recorded in any comet. While typical comets might have a carbon dioxide to water ratio of around 0.7, this interstellar visitor was clocking in at 8.1. That means for every drop of water vapor detected, there were 8 times as much carbon dioxide. To put this in perspective, imagine finding a car that runs on pickle juice instead of gasoline. That's how bizarre this discovery was to people who study comets for a living. Even 2I Borisov, the last confirmed interstellar comet, had ratios that made sense within known physics. But 3I Atlas was operating on completely different rule. The Webb telescope's instruments caught the carbon dioxide signature at 4.26 microns, a spectral line so strong and broad that there was no mistaking what they were seeing. Water was there too, but it showed up as barely a whisper compared to the carbon dioxide flood. The production rates were staggering. This comet was venting carbon dioxide like a broken soda machine in space. What made this even more puzzling was the distance. 3I Atlas was still 6 astronomical units out way past Jupiter, where sunlight is weak and most comets stay dormant. At that distance, water ice barely gets warm enough to turn into vapor. Yet, this object was already developing ghostly tails and showing activity that shouldn't start until much closer to the sun. The main engine driving all this activity wasn't water like every other comet in our solar system. It was carbon dioxide, and lots of it, the metal that shouldn't be there. While the carbon dioxide discovery was shocking enough, Webb's deeper analysis revealed something even more disturbing. Spectral lines for nickel started showing up almost immediately. Clear and undeniable signatures scattered across the ultraviolet and near-infrared ranges. The team initially thought their instruments were malfunctioning. Cosmic ray hits or calibration errors seemed more likely than what the data was showing. But line after line, the evidence mounted. Nickel signatures at 3,415 angstroms, 3,524, 3,769, and multiple other wavelengths painted a consistent picture. By the time 3I Atlas reached 2.85 astronomical units from the Sun, it was spewing out more than 10 to the power of 21 nickel atoms every single second. Here's where things got really weird. Every meteorite, every comet, every piece of space rock ever studied has shown nickel and iron traveling together like cosmic twins. The ratio is predictable. roughly 1 part nickel to 15 parts iron, give or take. It's been this way since the formation of our solar system, and presumably every other star system we've studied. The 3I Atlas was breaking this fundamental rule in the most dramatic way possible. Iron was completely missing, not just low levels, not just hard to detect. The European Southern Observatory's most sensitive instruments, running at resolving powers of 80,000, found absolutely nothing in any iron channel they checked. The upper limits were brutal. Nickel was outnumbering iron by more than 40 to 1. Assuming any iron existed at all, it was like finding a gold ring with no trace of copper or silver anywhere in the metal. Something's pushing this thing around. The chemical mysteries were just the beginning. As tracking stations around the world monitored 3I Atlas's path through space, they started noticing something that made veteran astronomers nervous. The comet wasn't following the neat, predictable curve that gravity should dictate. Instead, it was accelerating in ways that seemed to ignore the laws of physics. Over 72 hours of careful observation, the object's velocity increased by nearly 0.12 ms squared. For something 11 kilometers across, this kind of acceleration would be like watching a cruise ship suddenly pick up speed without engines, wind, or any visible means of propulsion. Solar radiation pressure and normal outgassing couldn't account for numbers like these. The Pan-STARRS tracking network designed to spot potentially dangerous asteroids logged every deviation with increasing concern. The acceleration wasn't smooth either. Tiny, sharp jumps appeared layered on top of the main velocity increase, like something inside the object was flickering on and off. Each update from ground telescopes showed the same pattern. 3I Atlas was being pushed around by forces that didn't fit any known model of comet behavior. The Minor Planet Center double-checked all the raw data for software glitches or calculation errors. Everything held up. The acceleration was real, consistent, and completely unexplained by current understanding of how space objects should behave. This wasn't the slow, steady push of solar wind or the occasional burp of gas from a warming comet. This was something else entirely. When ancient kings held pieces of the sky thousands of years before anyone understood what meteorites were, ancient craftsmen were working with metal that fell from the heavens. In Egyptian tombs dating back over 5,000 years, archaeologists have found iron beads with a secret that modern science can read like a fingerprint. These tiny cylinders, hammered thin and rolled into perfect tubes, contain nearly 1/3 nickel. No furnace on Earth in 3200 BCE could have produced that ratio. The famous dagger buried with Tutankhamun tells the same story. After more than 3,000 years in a tomb, the blade remained untarnished and sharp. X-ray fluorescence testing revealed 11% nickel content, plus traces of cobalt that only appear in iron meteorites. The Widman-Staten pattern, those distinctive crystalline bands that form only in the vacuum of space, lies hidden within the metal structure. Ancient Babylonian tablets speak carefully of stones that rain from the sky and stars that burn. Their word for iron and bar appears in lists of precious materials alongside warnings about disasters from above. These civilizations couldn't understand the chemistry or physics involved, but they knew that when metal fell from the sky, it was different from anything they could mine from the earth. The Manchester Museum's collection includes dozens of these ancient artifacts, each one carrying the same cosmic fingerprint of high nickel content. From Egypt to Mesopotamia, royal tombs contain blades and jewelry forged from fragments of shattered worlds. The metal was both treasured and feared, seen as gifts from gods or omens of coming disaster. The clock that keeps perfect time. As if the chemical anomalies and unexplained acceleration weren't puzzling enough, phototrick data from the Gemini South Telescope and the TESS Space Observatory revealed another layer of strangeness. 3I Atlas was brightening and dimming with clockwork precision every 7.2 hours. This wasn't the slow, irregular tumble expected from a jagged chunk of ice and rock. The light curve was sharp and mechanical, like a lighthouse beam sweeping across space with perfect timing. Even as the comet increased its outgassing activity and developed its ghostly tail, the period never varied. For a normal comet, spinning should slow down as gas jets act like tiny rocket thrusters pushing against the rotation. But 3I Atlas kept its rhythm like a Swiss watch. Some astronomers tried to model this as reflection of flat surfaces, perhaps sheets of ice or unusual crystal formations. Others suggested the object might be hollow or have an extremely unusual shape that could create such regular light patterns. Every explanation came with new problems. The brightness variations were too sharp, too consistent, too perfectly timed to match any known natural process. Veterans of astronomical observation couldn't help remembering Oumuamua, the first confirmed interstellar visitor that also showed unexplained acceleration and unusual light curves. The parallels were impossible to ignore, but 3I Atlas was bigger, brighter, and its timing more precise. Where Oumuamua left scientists with questions, this new visitor was providing answers that nobody wanted to believe. Scientists pick sides in a cosmic mystery. Harvard astrophysicist Avi Loeb didn't wait for committees and peer review to weigh in on 3I Atlas. His direct question cut straight to the heart of the matter. What kind of natural process could make a comet behave like this? The nickel without iron puzzle, the precise acceleration spikes, the mechanical light curve. Each anomaly by itself might have an explanation, but altogether they painted a picture that conventional astronomy couldn't easily explain. Inside the Webb and Pan-STARRS teams, opinions split down the middle. One camp pushed for exotic chemistry explanations. Maybe 3I Atlas formed in a carbon-rich nebula where ions stayed locked in mineral form while nickel formed volatile compounds that could vaporize in space. The carbon dioxide dominance could fit this model if the parent star system had completely different chemistry than our own. The other camp found themselves considering possibilities that would have been laughed out of academic conferences just years earlier. The regular light curve, the precise acceleration patterns, the impossible metal ratios. Could these be signatures of something built rather than born? A fragment of technology from a civilization so advanced that their waste products looked like comets to our instruments. Lab data offered one tantalizing clue. Nickel tetracarbonyl, a molecule so volatile it vaporizes at 43 degrees C, could form under the right conditions. Mix carbon monoxide-rich ices with metallic nickel, add some ultraviolet radiation, and the compound could drift into space before breaking down to release atomic nickel. Iron's cousin compound is much more stable and wouldn't show up in spectra. This could explain the missing iron, but only if the parent body formed under conditions unlike anything in our solar system. What this means for everything we thought we knew. The implications of 3 Atlas extend far beyond astronomical catalogues and research papers. If this object represents natural processes we've never encountered, it suggests the universe is far stranger and more diverse than current theories predict. Star systems might form under conditions so different from our own that their leftover comets operate on completely alien physics. But if the mounting evidence points toward artificial origins, the questions become even more profound. A light sail designed to ride solar radiation could explain both the acceleration and the sharp brightness patterns. Such technology would require engineering capabilities beyond current human achievement, but well within the realm of possibility for a sufficiently advanced civilization. NASA's Planetary Defense Office quietly flagged 3I Atlas as a high anomaly, a classification usually reserved for objects that might impact Earth. This wasn't about collision risk. It was about an object that didn't fit any known category, requiring new protocols for investigation and analysis. Internal risk matrices had no boxes to check for visitors that might be artificial. The debate spilled into scientific forums worldwide as astronomers dissected every data point. Social media threads exploded with speculation, while established journals struggled to handle papers proposing explanations that ranged from exotic physics to extraterrestrial engineering. Each new observation added fuel to arguments that were reshaping how scientists thought about interstellar visitors and the possibility of intelligence beyond Earth. For the first time since the space age began, astronomers found themselves seriously discussing whether humanity had detected technology from another star system. The evidence wasn't conclusive, but it was compelling enough to force conversations that science fiction had explored for decades. 3 Atlas had become more than an astronomical curiosity. It was a mirror reflecting our deepest questions about whether we are alone in the universe and what it might mean if we're not. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.